We've spent the past 2 or so weeks on kinetics, and the last lecture wrapped up discussing the initial rate method. So we talked about these graphical methods that use the integrated rate laws. And we could predict the amount of material that is used or is left or is produced after a certain amount of time. So with the initial rate method, we are looking at concentration versus rate. With the integrated rate laws, we are looking at concentration versus time. Today we're going to talk a little bit about half-life, which is related to the integrated rate laws. In fact, it's an integral component of the integrated rate laws, and using the half-lives to predict. It's just a term, it's a amount of time associated with a particular rate law. And then we're going to move on to looking at temperature effects. The temperature's effect on the rate. So the rates versus temperature. This is another method that we're going to look at. This has a direct impact on what's going on at the molecular level. And again, this ties back to thermodynamics, why the reactions take place or don't. Which ultimately leads us to the mechanism. The mechanism is what's going on at the molecular level. And within the mechanism are what we call elementary steps. And the elementary steps describe how the reaction proceeds. Associated with this is one important fact, it's the rate limiting step. All of these bits together will be applied towards reactions that compete with one another and ultimately equilibrium.